Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss the concept of metacenter and metacentric height. In our previous theory lecture, we have discussed the concept of buoyancy and center of buoyancy. So this metacenter and metacentric height also related to the concept of buoyancy and force of buoyancy. So to discuss this concept, let me go to the previous topic what we have discussed. Okay. So there is a water surface line is there, and in this a body is floating, suppose. Okay, now here the water which is present here, the density of this water obviously more than the density of the object which is floating. If the density of this floating body is more than the density of this liquid, then it is going to sink inside the water. For this floating condition, the density of this body is less than the density of the fluid which is present here. Okay, that is one part is there. Okay, now for the previous videos what we have discussed, so the center point of this, or the center of gravity of this body, will be somewhere at this middle point of this object. Okay, and that is denoted by G point. Okay, and here also the weight of this body is going to exist here. So that's one we can give W at the center point, and which is always vertically downward. Now the force of buoyancy which is opposing the object to go inside, or which is trying to be the body is supposed to be in up, moves to the upward. So that force of buoyancy is acting at a point B. Okay, and that force is known as force of buoyancy, that is FB. Okay, so previously we have seen this is the concept, G point and B point, and the force of buoyancy which is acting on this, at this B point, center of buoyancy point. Okay, now the center of gravity and center of buoyancy both are existing at the same line, same axis line. Both points are coinciding, and here for this condition we have seen the weight of the body is equal to the force of buoyancy. Okay, and for this condition, if you see, the metacenter also will be existed in the same line, in the same axis line, but it's not able to identify at which point the metacenter is there. Okay, so to identify or to find out the metacenter of an object, we need to tilt the object with some angular displacement. Okay, so let's extend this water surface, and the same object, what I'll do after rotation, after some angular displacement, let me rotate this object, and how it will be like, it should be this way. Okay, the same liquid is there, water what I have taken previously. So this is the liquid which is previously considered. Yeah, now the same axis line if I draw, then the axis line will be in this. Okay, yeah, now if you see, the G point of this body also will be existed in the same point like what was previously there. Okay, so this is the G point, center of gravity point, as usual like previous. Now the B point which was initially at this position, now for this, after this rotation of this body, okay, after tilting the body, okay, now the B point is going to change actually. Okay, the B point which was there previously, now it is going to change from this B point to B1 point. The B point is same, the point of B is not going to change, but the force of buoyancy which was acted initially at this B point, that is going to change from B to B1 point. Okay, now it is going to act on this point. The force of buoyancy is going to act at this point. Okay, this is due to previously it was in the equilibrium condition and is in the balanced way, so there is no point of a difference of G and B point. Okay, now when it is tilted, that means the object was a little bit rotated to some with an angle. Now that's why the force of buoyancy is going to change its position. Okay, initially it was here, now it is going to change at this point. Okay, so these were the changes happened compared to the previous one. Okay, so G point is their center of gravity point. Now the center of gravity, the weight of the object will be acted at this point, so that weight of this body which is acting here, that is always vertically downward, we know that, and this will be act here, W. Now the FB point, the force of buoyancy which is acting at this B1 point. Okay, if you extend this line, up to this axis line, then we can see a meeting point of here. This is the meeting point of this line of action of this force of buoyancy or buoyancy point, and the meeting point of this axis line and the line of action. This point is known as M point. Okay, and that is known as metacenter. So exactly what if it is the question is given to define the metacenter, how we can define, we can say the point at which the line of action, of the force of buoyancy, this is the force of buoyancy as I told you, FB, the force of buoyancy, the line of action of force of buoyancy will meet the normal axis. Normal axis is already, this is the normal axis. See, normal axis will be always it in a perpendicular to the object, so that's why it is perpendicular. Okay, the normal axis line, and where the body is given small angular displacement, or it is going to tilt some angle. Okay, then we can find out the point at the metacenter point, and the metacenter point is defined as the M, capital M. Okay, that is metacenter, and the metacentric height is nothing but, the metacentric height is the distance between the metacenter and the center of gravity. Okay, the distance between this center of gravity to the metacenter point is known as metacentric height. Okay, so this is concept actually required to find out whether a object is stable condition or unstable condition or in a neutral condition. Okay, so when the boat is floating on the sea, you can see the impact of waves on the boat or on the ship, and the impact of wind. Okay, there will be heavy wind during the winter season, in the rainy season, if you see. So that time, to find out the impact of winds and waves on the ship, okay, it is very much essential. So because we need to find out at which condition, if that ship is tilted this much, then what is the possibility, what should be the weight at that other end to make it in the equilibrium condition, or what can be done to make it in the stable condition. So there is a lot of concept regarding that to find out stability and instability. So this is the concept of metacenter and metacentric height. So I hope you understood the metacenter and metacentric height. If you are having any kind of query and doubt regarding this, you can give a comment. Thank you.